And we'll move on straight away to you, Narasimha, and provide you with the same input. And I guess you're going to get a bit more connection to perhaps energy and development. But over to you, Narasimha.
Thank you. Well, it's a great pleasure to be part of this panel. In my comments, I'd like to describe a few of the sustainability challenges in the developing countries in particular, as I see them, and then reflect on a few of the lessons that we have learned in our work at IIASA on how scientific research can help surmount some of these sustainability challenges. So up to now, you've heard a fair amount this morning on the importance of inclusive growth and poverty alleviation, and also you've heard about the critical importance, or one aspect of raising the living standards of the poor is infrastructure. And more than 20% of the world today does not have access to the basic services and infrastructure that we rely on and take for granted. For instance, 3 billion people today burn solid fuels for cooking directly, coal, wood, and dung, leading to indoor air pollution, which, as you've heard before, leads to many deaths, premature deaths, particularly of women and children. As another example, 1.4 billion people lack access to electricity. And you've heard before that not only is this impinge on quality of life, but it also denies people opportunities for livelihood, health, and education. 1.7 billion people face water shortages due to a lack of a delivery infrastructure. And as shown in this picture, this includes people who may be physically close or located to water resources or infrastructure, but still do not have the ability to access them. And the conditions for sanitation are even worse than that. And finally, roads. 1 billion people lack access to all-season roads, which denies them access to markets to sell their products. So history tells us that in order for raising living standards and providing infrastructure, energy needs to increase significantly. And we do actually understand that there is a correlation between the amount of energy countries use and human development. So for instance, if you look at the poorest countries who are concentrated in sub-Saharan Africa and Asia, they have very low levels of human development, according to the Human Development Index, and consume small amounts of energy. And at those levels, increases in energy are not so consequential. In the other extreme, you have OECD countries that enjoy very high levels of development and consume a lot of energy, and as you can see clearly, with decreasing returns to human development. But beyond a certain point, there is in fact a strong correlation. And it is interesting that if you look at all countries, there isn't a single country that has achieved the living standards of OECD countries by consuming less than 100 gigajoules per capita. And so this is sort of an imperative for growth for the poor countries. And of course, we're interested in the services that energy provides, and we're interested in efficient growth, but the growth imperative is strong, especially for poor countries. And it suggests that if history and current development patterns are a guide, there needs to be a 2 to 3-fold increase in energy in the poorest of countries. Now, how sustainable is that? Well, historically, industrialized countries have relied on a 20-fold increase in energy in development, which has come primarily from fossil fuels, coal, oil, and gas. But in the future, if we are to respect the constraints of climate change, developing countries may not have that option. Now, you've seen this before in Kewan Riahi's presentation yesterday, that if we want to achieve the 2 degrees C target, global emissions have to peak in 2020 or so. But what does this imply for developing countries? Well, if you take the most ambitious and optimistic scenario where Annex 1 countries, the industrialized countries, reduce their emissions starting today and very drastically, it would still require that non-Annex 1 countries, the developing countries, their emissions peak between 2020 and 2025. So we're talking about a 2 to 3-fold increase in energy and a peaking of emissions in the next 5 to 10 years. And the only way to achieve that is a radical transition to a low-carbon economy. And in many countries that can ill afford the technologies that requires. And if that sounds pessimistic, the flip side of it is that it's also an opportunity because developing countries aren't locked into the infrastructure in developed countries. And so in some sense, there is an opportunity for creating new technologies. And as Michelle was talking about new transformative technologies, we need new technologies, but I would like to argue that it also requires technologies that are developed for and in developing countries, and to create the enabling conditions for them, such as making them affordable. Let's take another example. Vehicle growth is also associated with increasing affluence. And it's well illustrated by the history of vehicle growth in the United States, for example. If you compare the vehicle stock in developing countries of, say, for example, India and China, today they have levels of vehicles that correspond to what the US had prior to World War II. And why is that? Well, this is explained by the modes of transport that are prevalent in developing countries. For example, in South Asia, 70% of passenger kilometers are public transport. And if you think about it in terms of actual trips made, over half the trips, in fact, are by cycle or walking. But this is changing with growing affluence, and it is expected in the next 20 years that vehicle stock will increase significantly, by a factor of 3 in India, for example, and a factor of 5 in China. What is the sustainability challenge here? Well, among other things, this vehicle growth is happening in cities, and many of these cities are amongst the most polluted in the world. Here, these are the particulate levels of the most polluted cities, and as you can see, many of these are in the countries where you're experiencing vehicle growth. And even at today's vehicle levels, you see that they have particulate levels that are 4 to 5 times higher than what is recommended for safe levels by the World Health Organization. And as you've heard before from Zig Clement's presentation, the ill effects of particulates are significant, not to mention other aspects of social ills created by vehicle growth, such as fatalities from accidents and congestion and so have you. So again, we have a challenge, but the positive side here again is that there are co-benefits for reducing particulates, for health, as well as for climate and for the environment. And as long as we can create the enabling conditions for a transformation to a clean transport infrastructure. Well, what are these enabling conditions that I'm talking about? Of course, there are several dimensions to it: cooperation, behavioral issues, but technology is an anchor, and many other experts in this room are well versed with the challenges for technology R&D and innovation, but I want to focus on the issue of deployment. That is, the scale-up that is required in developing countries to disseminate is unprecedented, and that raises new challenges or additional challenges for scientific research. And I'd like to raise a few of the points that from our research we see are important for the successful deployment at the scale that is required. The first is context, that is understanding the conditions where technologies are deployed. So if we take the example of affordable modern household fuels, we've done research on understanding the heterogeneity in households, one aspect of that being income heterogeneity. And what this shows you is for different income groups, each line representing a different income group, different levels of policy support will get you different levels of access based on how many people can actually adopt modern fuels. So for example, urban high-income households in sub-Saharan Africa require hardly 5% fuel support, whereas the lowest income groups, it's not sufficient to support fuel. Even at zero fuel prices, they need support of the appliances in order for them to be able to adopt modern household fuels. The second point is governance. Technologies need to be well governed. You've heard this morning that electricity access is inequitably distributed not only across countries, but within countries, as this map of India shows. But what is less understood, and what we are working on understanding right now, is the extent of poor reliability, even in areas where you have good electricity access. And so households experience outages in rural areas of 4 to 12 hours a day, every day. And this is not just a problem restricted to India, it's across sub-Saharan Africa as well. And what this does is, as you also heard before in the morning session, is it means fewer businesses and less income. And so the message here is in looking at technology solutions, we need to think of the benefits more broadly, not just in terms of physical access, but in terms of the energy services that technologies provide. And the third point I wanted to mention is that technologies need to be consistent with policy priorities in the context where they are deployed. And here I refer back to the tools, again, K1 Riyahi talked about, that is, we look at the different policy impacts around different dimensions and in order to determine the impacts of particular technologies. So if you look at the transition to modern cook stoves again, as an example, we see that in achieving 100% access and providing policies to enable that access, we can reduce the amount of energy used because shifting away from directly burning biomass and moving to improved cook stoves that burn gas are much more efficient, and so to provide the same useful cooking energy, they require a lot less fuel. So you significantly reduce energy. A second dimension is greenhouse gas emissions, and there's a net negligible effect because even though there's an increase in CO2 from burning more fossil fuel when you use gas, there is a reduction in the other non-CO2 greenhouse gases such as carbon monoxide and methane from moving away from directly burning biomass. And a third dimension is that of the lives lost from indoor air pollution, that in not burning biomass directly, you save over 1 million lives a year. So it seems from these dimensions that moving to improved cook stoves perhaps is one aspect of infrastructure growth that is sustainable and is one solution that we need to try and replicate in other forms and in other service needs. So in conclusion, I want to leave you with a couple of messages. The first is there is a large infrastructure gap. It's daunting. And current trends and how that gap is being filled offer challenges for sustainability, both from an environmental perspective and an equity perspective. But the second point is that it's an opportunity. It's an opportunity for developing new technologies, as I said, for and in developing countries. And we need scientific research to shed light on the needs and conditions in which these technologies have to be deployed, and to enable us at a system level to understand the entire dimensions along which they affect human well-being. Thank you.